Hello, ladies and gentlemen, and welcome back. Root Beer here, and I'm on the very last question of our 2016 Pascal contest. A 0 or a 1 is to be placed in each of the 9 1x1 squares on the 3x3 grid shown, so that each row contains at least one 0 and at least one 1, and each column contains at least one 0 and at least one 1. The number of ways in which this can be done is, and those are some big numbers, so we probably don't want to list them all out. I think that would be a massive waste of our time, but we could probably break this down into cases. Okay? We know each column has at least one 1 and at least one 0, so that sort of gives us a minimum. How do I want to say this? We're never going to try to place 2 zeros in the grid and 7 ones. I mean, there's 9 numbers that we're placing in total. Some of them are zeros, some of them are ones. But you'll never have all ones because, well, you need to have some zeros. You need at least 3 zeros, 1 per column. You might need more, maybe if the placement in the columns doesn't line up with the placement in the rows. But I think some sort of like diagonal action will hit all the rows and columns. So you could have 0 3s, and therefore 6 1s. And I think as long as you place the 3s, you'd be fine. That should work. Or alternatively, we could have three 1s and 6 zeros, and those sorts are sort of mirror images of each other. If there's a way for me to place 3 zeros in the column in the grid and 6 1s, change all the zeros to 1s, and everything should still be satisfied. And so there's also, you could have 4 zeros and 5 1s. And alternatively, if you swapped all the zeros and 1s, you could have 4 1s and 5 zeros. I think that'll be trickier, but certainly I think it's doable. I mean, that's not many cases to work on. So 3 zeros, 6 1s. Every row needs a 0 and every column. So we should focus on placing the 0. So we could do, this. We could do the other diagonals. But there's more that we could do. And sort of so I've got 3 places in this first column to place a 0. So 3 choices for my first 0. As soon as I've got that down, that 0 has to be the only 0 in this row. And so when I go to my second column, I have 2 choices for the placement of that other 0. And as soon as I place that 0, that forces, there's only 1 choice of place for the 0 in the last one. So there should be 6 ways to place the zeros. Does each one lead to a decent way to play? Is there any complication from the 1s? I don't think so. How can we be sure that that every row or column has a 1 if all we've done is place the zeros? Well, if the 1s fill in every other spot, the only way I could not get at least one 1 in a column is if that column had all 3 of those entries as 0. So with our situation, these 3 zeros, well, there's only 1 per column, 1 per row, so every column will have 2 other free spots. Every row will have 2 other free spots, so you're guaranteed to get 1s. So there's 6 ways to place 3 zeros and 6 1s, and by swapping zeros and 1s, there's going to be 6 ways to place 3 1s and 6 zeros. So that's one case done. So 2 times 6, 12 ways. So that's the 3 zeros, 6 1s, 3 1s, 6 zeros. And the only other possibility would be 4 zeros and 5 1s. And of course you could have 5 zeros and 4 1s, but that's just going to sort of be a mirror image or a swapping of zeros and 1s. Okay. Now, in my first column, so the same sort of counting argument shouldn't necessarily work, I don't think. Because if you give each column a 0, there's going to be a 0 left over. So one column gets 2 zeros. One row gets 2 zeros. There's 3 ways to pick that column and 3 ways to pick that row. Is it possible for 2 columns to get 2 zeros? No, because then you'll have a column that's left out. So give each column a 0, and then one column will get an extra one. So there's 3 ways to pick it. So say I pick the first column and the second row. That forces a 0 to go here. And then there'll still be another 0 in that row and another 0 in... another 0 somewhere here, another 0 somewhere here. And then... So when I consider my remaining 2 columns, one of them will have to be a 0 in that row. So of my remaining columns, choose 2 of them, and that'll be the one that gives me the double 0. These aren't ones, I'm sort of crossing out the rest of the column and the rest of the row. I didn't know if that was clear. And of the remaining rows, one of them, you've got 2 choices of row, and one of them will have to have a 0 in this first column. And then by default, the overlap between the column not chosen and the row not chosen gives me a 0 somewhere else. So that should be 3 times 3 times 2 times 2. 36 ways to do this. Well, let's see if that'll work with some arbitrary. Let me make my choices ahead of time. So I'll pick this row and this column to get the double 0. And I'll pick this column to get the second 0. And this row to get the second 0. So that forces it to go there. That forces that to go there. And so the leftovers, that's this column and this row, must get a 0 as well. Okay. Is there any way that this will end up giving me 3 zeros in a row? No, because the only time we double up on something, we are choosing that. There can't be a third 0 here, because then this row would get nothing. So that should be 36 ways, so 72. So 2 times 36. 72 ways to get 4 zeros, 5 ones. So I think that should work. So 72 plus 12 should be a total of 84. Is 84 one of our possible answers? It is not. Interesting. So, am I missing something? Am I double counting and still missing something? I thought my reasoning was pretty good there. So I definitely think it's 12 ways to do this. I don't think there's a flaw there. There's no ways to do... I did read the question right. Each row contains at least one 1 and at least one 0. Each column contains at least one 1 and at least one 0. Fine. Okay. So 3 times 3 and then 2 times 2, it should be 36. Unless there's another situation I'm not accounting for. So one column gets 2 zeros, one row gets 2 zeros. Oh, is it possible? I said this row gets gets an extra 0, this row gets an extra 0, and I just put a 0 here. Is it possible that maybe there isn't a 0 there? So there's another case. So if extra row and column overlap to a 0, 36 cases. If the extra row and column overlap or intersect at a 1, is there something I can do there? So again, I'll pick this one and this one. They'll get 2 zeros each. If I put a 1 there, well, that forces the zeros here and the zeros here, but that still makes everything good. And so there should be 9 cases there. So that would be give me a total of 45 cases. So if they intersect in a 1, that forces that. If they intersect and I choose it to be a 0, then we've got to get everything. We've got to choose another column to get a 0 here, and we have to choose another row to get a 0 here. And that forces another one here. Okay, so it should be 45 times 2 will be 90 plus the previous 12. The answer should be 102. Is that one of the possibilities? Yes, it is. It's D. So I think to close off our 2016 Pascal, the answer is D. All right. So it's been a good paper, I would say, overall. I'm glad I managed to catch that other case. I would have had a real problem if 84 had been one of the answers. Fortunately, it wasn't. But, you know, it didn't take too long, I would say, to find this extra case, and that I had made the assumption that there was an overlap. Anyway, as I say, it's a good paper. So that's the 2016 all squared away. If you're looking for more grade 9 level material, 2017 Pascal or 2015 might be up your alley. Or if you want still grade 9 level but written contest, the Friar is something to look into. I go through many Friars. 2016 Friar should be coming up shortly. So by all means, take your pick. That's it for me. So have yourselves a wonderful day, and I will see you in a future video.